Let's understand the graphical representation of pretty much everything. So first we need to understand the definition, but I would start off by looking at naming convention. Once we understand all of this, defining it and talking about this will be much easier. Right? So we'll begin with naming convention. The convention is this. First, we'll always talk about the dependent quantity versus the independent quantity graph. For example, distance versus time graph. Here, the dependent quantity is distance and the independent is time. One more example is inflation versus time graph. So here inflation is your dependent quantity and time is your independent quantity. Next we'll look into an important tool that is useful with every graph. That is the slope of a graph. To define it, we have dividing the change in height by change in horizontal distance, or dividing the change in dependent quantity divided by change in independent quantity. How does it sound like? It sounds like rate of change, is it not? Change in dependent divided by change in independent. We can define it this way also. Because generally along the x-axis we have the independent and along the y-axis we have the dependent. A slope is change in, I've written here itself, or you can write it this way, change in y divided by change in x. So here I have a graph. This is the change in, let me actually complete the diagram. So this is your change in y and that's your change in x. From point A to B is your change in x and B to C is your change in y. That is your definition of a slope. So how to find the slope? Well, say this is a graph that is given to you and they'll ask you to find the slope. The procedure is over here. Take 2 points along the line whose slope we are trying to find. This is a small tip. Choose 2 points that are far apart to each other. This makes your calculation more accurate. So whenever you're trying to find a graph of a straight line, take 2 points which are a bit far, like say these 2 points. So we took 2 points, okay. Find the coordinates. This is 4, 2 and this is 16, 4. Okay, we did that. Use the formula to find the slope, and the formula is this: slope is equal to change in vertical distance divided by horizontal distance. So from here to here is your change in horizontal distance and this is your change in vertical distance. So how do we find this? Simple. Change in vertical distance is from here to here, that is from 2 to 4, right? Can you see that? It's from 2 to 4. So there has been increase. So this is from 2 to 4, 4 minus 2, and horizontal distance is from this length to that length, right? This length to that length, and it's the same over here obviously. So 16, 4 to 16, so 16 minus 4. So the difference is 2 and over here it is 12, so 1 by 6. So every unit of change in x will have a change of 1/6 change along the y. You'll understand that later. So we use the formula. Always subtract the coordinates on the leftmost point from the coordinates of the rightmost point. We did that. 16 and 4, 4 and 2. Remember to include units in your answer. unit here is unit 2 and unit 1. So numerator will be unit 1 divided by unit 2. So this is how you find a slope. See, slope is same as finding the rate of change. Okay, so rate of change and slope is one and the same. So how do I tell that? See, look at this 1 by 6. So if you actually look at this value denominator, for every 6 unit there is increase of y by 1 unit. So let's look at this. So 6 unit means we have 10, right? So if I increase from 4 to 10, and you can see there is an increase in y by 1 unit. We generally talk about denominator being 1 and the numerator being whatever it is, but that would be very complicated over here, because 1 by 6 then has to be rewritten as 1 by 6 divided by 1. And 1 by 6th in a particular graph would be difficult to see. So we can observe in this manner as well. So remember, rate of change and slope is one and the same. We discussed this over there. I told you what is rate of change graphically mean. It means slope, and we are trying to find the slope over here. So all of this will add up. Okay, all of this will add up. So you need to understand all the aspect. Again, this is not something that is just being used over here. It will be used in your degrees. It will be used in your 11th and 12th, in whatever course you take up. Anything that is to do with any growth or business analysis or any kind of analysis, everything deals with rate, graph, statistics, and all of it. So you need to understand this, right? So now let's look at the definition, or a way of putting graphical representation across. Basic line graph shows dependency of one physical quantity, such as distance or velocity, on another quantity such as time. So this is nothing but your definition of rate of change. Rate of change or slope. That's the very definition of rate of change and slope. Okay, not or and slope. This is your naming convention, always the dependent first and then the independent. And we discuss about the slope. From a graph, how do you find the slope? It's very simple. Look at the change in y and look at the change in x. Dependent minus independent changes. So that's another way of putting it across. And we have an example over here. This is the procedure of finding a slope. Okay, including this, of course. End of it, this mathematical part will come. And this is your rate, right? Slope and rate is one and the same. And now it's time for you guys to copy this.